Alright, first thing I need you to have is 4 pieces of paper. Okay? I've got 4 pieces of paper. Do you see how far I have them spaced apart? Something like this. Okay? So what I'm going to do is I'm going to fold the bottom underneath so that when I fold these down, I get like that. Now I know these 2 middle ones are going to be the same color. There's no way around that. Okay? Yeah, just like that. And then when I get them all like this, I'm going to hit up here at the folded edge. I'm going to staple it. Okay? I'm going to staple it 3 times. You can staple it twice. 7 is too many. Guys, this is not arts and crafts. This is folding paper. Mostly in half-ish. Okay? I haven't done anything yet. To slow down. The first thing you're going to do is turn it on the back. And you're going to write your name in something that is not pencil. Okay? You're going to write your name in something that is not pencil. Because if you write your name in something that is not pencil, you may use it on our next test. Everybody hear me? Yes. Okay? Now, some of you, because of the colors you chose, pencil is not the best choice for writing today. The darker paper, it's hard to see pencil. So if you want to use pen or marker, I've got some markers back here on my desk. It's up to you. Okay? Those. If you write your name on the back with something that's not pencil, then you can use this on your next test. Like when it's time to take the test, you can get this out and use it on the test. Correct. Paper or iPad? Okay. It should be on. If not, let me know and I can turn it on. Yes, please write that. Is it there? Is it there? Okay. Okay, you ready? So now notice how we're going to use each of these as tabs. We're going to write something on the tab, and then we're going to fold this up so that we have room for examples. Okay? Somebody grab the door, please. Thank you. So our first tab is going to say product of powers. Product of powers. So we're going to write the name of the rule and then what the rule looks like. And then we're going to write examples. Fair enough? Okay. So the product of power rules looks like a to the m times a to the n. If I'm multiplying like bases, what do I do with the exponents? Add. So what's that going to look like? A to the m plus n. Okay? Any questions about that? So fold this up. Now you see how we have some room for some examples? For example, x squared times x to the third equals what? Using the rule that we just wrote down, what do we get? What is 2 plus 3? Yeah. X to the fifth. Does this rule work when our exponents are fractions? What do you think? We're multiplying like bases. What do we do with the exponents? So what's 1/3 plus 1/3? 2/3. X to the 2/3. Done. Yes? Okay. So our next tab, power of powers. What do you think that will look like? If product of powers looks like this, what's power of powers going to look like? Like multiple, right? Okay, so if I have a to the m being raised to the n power, what's that going to equal? When we have a power raised to a power, what do I do with those two numbers? Multiply. Are you referring back to anything in your brain? Yesterday, right? The worksheets we did yesterday? This was to kind of help you remember that. And so we can go forward. Okay? So power of powers, a to the m raised to the n, we say m times n. So for example, if I have a squared to the third power, what would that be? A to the sixth, because 2 times 3 is 6. Okay? Does it work when we have fractional exponents? X to the 1/2 being raised to the third power? Yes, because what's happening is I have 1/2 times 3, but that's really 3 over 1, right? And how do we multiply fractions? Straight across. What's 1 times 3? 3, good. What's 2 times 1? 2. So I should end up with x to the 3/2 because that's what I got when I did the multiplication. Okay? Questions? Power of a product. What do you think that's going to look like? Excuse me. Probably. It's going to have an exponent. What's that? Yeah, a multiplication problem, right? It's a power of a product. So I'm going to have something being multiplied and then being raised to a power. So it's going to look like this. AB to the m power. What is being raised to the m power? Everything inside the parentheses, right? A and b, correct? So I should get a to the m, b to the m. So some examples. We'll start really simply first of all and say xy squared. What's that the same as? Perfect. X squared, y squared. But now we have to do little combination things. Okay? What if we have xy to the third all to the fourth power? Isn't that kind of a combination of this rule and some other rule? The power of powers rule? So what do you get as your answer? X to the fourth, y to the 12th. Oh yeah. See, that's how you know I'm a gangster. Not really. Okay. Now I need to try to trick you. You ready? Well, I'm going to do it anyways. Okay. Two x squared y z to the third, all being raised to the fifth. What do you think? That's very, very close. Very close. What is being raised to the fifth? Everything or just the variables? Everything, right? So we have to have 2 to the fifth also. Is 2 to the fifth power 10 though? What's 2 times 2? Times 2 times 2 times 2. 32. That's 2 to the fifth power. 2 5 times, right? So that is 32. Okay? All the rest that you said was correct. X to the 10th, y to the 5th, z to the 15th. Because that's that power of powers rule, right? Okay? Questions? So what am I going to ask now? Does it work with fractions? X, y to the 3/4 power. X to the 3/4, y to the 3/4. Done. But now I got to try to trick you again. I'm going to do it anyways. Okay. Who was not here yesterday? All of y'all were here yesterday? Good. Then all of you should remember this. You told me that it's the same as regular exponents. Fractional exponents are the same, right? So what's being raised to the 1/2 power? Everything, including the 9. What is 9 to the 1/2 power? Y. And so raising something to the 1/2 power is the same as square rooting. Okay? So it is 3. Can we take the square root of x to the third? When we could try, we wouldn't be very successful. Because it's not an even power, right? It's an odd power. So we need to use these previous rules we've talked about. We need to multiply those two numbers. What's 3 times 1/2? Or 3/2, right? What's 5 times 1/2? 5/2. Okay? Questions? Quotient of powers. I was FaceTiming with my nephew last night, helping him with his math homework. One of his vocabulary words is quotient, and he's in the 3rd grade. Do you know what quotient means? I hope. Yes, it's absolutely division. Okay? Good job. You're smarter than a 3rd grader. Just teasing. Okay? All right, so quotient of powers is going to look like some sort of division problem, right? So we have a to the m divided by a to the n. Remembering back to yesterday, to your work from yesterday, what do you do when you're dividing like bases? What do you do with the exponents? Subtract them. Okay? A to the m minus n. So some example problems. What? Probably not. X to the 5th over x squared. What'd you tell me I did? Subtract. What's 5 minus 2? What do you get? X to the 3rd. Now, this problem is a little bit of foreshadowing for one of the tabs to come, but it's kind of a, we need to talk about it because we're talking about quotients. Okay? I started here in the numerator and subtracted the denominator and put the answer in the numerator, right? What if I did that here? If I started in the numerator and subtracted the denominator, what would I get? -5, right? Are we allowed to have negative exponents? No. So what if we started in the denominator and said 8 minus 3? Where would we leave our answer? In the denominator, x to the 5th. What's left in the numerator? 1. Good. Does it work when the exponents are fractions? X to the 5 halves over x to the 3 halves should equal x to the what? Okay?
2.
X to the 2? What are we doing with the exponents? Subtracting. What's 5 halves minus 3 halves? What's 5 halves minus 3 halves? 2 halves? 2 halves? Have you guys ever heard of 2 halves? X to the 2 halves? Isn't that x to the 1st power or just x? Yes? Questions? Power of a quotient. If the power of a product looks like this one, what is power of a quotient going to look like? So A over B to the n power. Okay? What's being raised to the n power? Everything. So A to the n over B to the n. Some examples. X over y squared. What's that going to equal? X squared over y squared. Good. X squared over y cubed to the 4th power. Yep, to the 4th power. What you got? X to the 8th, y to the 12th. Perfect. Now I'm going to try to trick you. 3x over z to the 4th squared. It's very close. Yes. Where do people mess up? Where do people typically mess up? With the square, right? They usually say 6x. 6x squared. Okay? It's 3 squared, not 3 times 2. It's 9x squared. And this is an error I haven't seen today. Okay? So I need to make sure to remind you guys of that. Okay? It's not 4, like it's not 4 squared, it's 4 times 2. So it would be z to the 8th. Yes, yes you did. Yep, you sure did. Does it work when our exponents are fractions? Okay. For instance, x over y to the 4/5 power. X to the 4/5 over y to the 4/5. Yep. Yeah, that's fine. All right, next tab. This is the one I was foreshadowing to earlier. Can we have negative exponents? Okay. We're not talking about physics. And even in physics, it just represents something like a small number, right? It's just a way to write a small number so you don't have to write like lots and lots of zeros in between the decimal and the other numbers, right? A to the negative n equals 1 over a to the n. This is one that people typically struggle with. So I'd like to tell you a really, really, really stupid story to help you remember how to do this. Okay? I know it's stupid going into it. I'm telling you that before I even tell you the story. Okay? But I'm hoping it'll help you remember how to deal with negative exponents. Okay? So I have this friend. His name is x to the negative 3rd. He's real nice, except he's really sad. How do you know he's sad? What's negative about him? His exponent, right? His exponent is negative, so you know by looking at him, he's very sad. right now, where is he living? He's living in the numerator, isn't he? Where does he want to be living? Or something close to that, right? The denominator, okay? You are a kind and benevolent person. That means you want to do something very nice for the x to the negative third. Because he's in the numerator, where does he want to go? To the denominator. When you move him to the denominator, guess what happens? He's so glad. And what's left in the numerator? 1. Shh. Then I have this other friend. His name is 1 over x to the negative fourth. Is he sad? How can you tell he's sad? Because he has a negative exponent. Where does he live? The denominator. Where does he want to live? The numerator. And when you move into the numerator, he is so glad. What's left in the denominator? A 1. Do I have to write it? Nah. You can if you want. And then he starts hanging out with friends. Another friend, right? Another one of my strange exponent friends. He hangs out with these friends. Who's sad? The y's sad. How do we know the y is sad? Because he has a negative exponent. Who else is sad? Negative 2 is not sad. Because it's not a negative exponent. Okay? So since the negative 2 is not sad, does he want to move? Where was he? In the numerator. He wants to stay in the numerator. Is the x sad? No. Where does he want to stay? In the numerator. Is the y sad? The y is so sad. Where does he want to move? To the denominator, and when you move him to the denominator, so glad. I don't have any idea. So that was really stupid, wasn't it? Numbers are not happy or sad, are they? Okay? I mean, they can make us happy or sad, especially if we make a low grade on our test or a low grade in our class, right? Numbers are not happy or sad. But maybe that will help you remember what to do with negative exponents. But it's only negative exponents and not negative numbers. That's the biggest problem. Okay? So just be careful what you're making happy. Fair enough? Okay? Does it work? I didn't even get to finish my question. Good job. What's it look like? One over x to the 1/2. Mm-hmm. Mm-hmm. The last tab that we have is going to say notes. Okay? The last tab that we have is going to say notes. And there's really only 2 things that we're going to put there, but they're pretty big deal. Okay? The first one looks like this. X to the 0 power. What? Yeah, you can write them big like that. What's anything to the 0 power? 1. That's a big deal. Okay? The other thing is going to be a big deal for the next couple days. I mean, from now on when we're talking about this unit, but specifically for the next 2 days, and I definitely want you to have it in your foldable for us to look back at if we need to. Okay? If I have x raised to the m over n power, I need you to know that the m is called the power and the n is called the root. I don't want an equal sign. Really? Uh-huh. How are you going to remember which one's which? Think of a tree. Where are the roots of a tree? On the bottom, right? Where does the tree get its power from? From the sun, from the top. Okay? Any questions about that? Okay? Probably you're going to need this foldable for the next couple days, so when you get in here, probably better get it out. Because look at what we're doing tomorrow. Look at what we're doing tomorrow. We are solving, where is it? Oh, solving exponential equations and inequalities. Okay? Does it seem logical that if we're going to be solving equations with exponents, I'm going to need some of these exponent rules? Okay, maybe, perhaps. Okay, perhaps. So please keep this with you. Like I said, if you can keep track of it, you will be able to use it on your test. Okay? Any questions about exponents or the rules about exponents? Peace.